Good morning and welcome boys. Mathematics of class 10. Today's topic. Today we start a new topic which is variation. What is variation? Variation means, roughly speaking, variable. The word came from variable. Variables and constant known to all of us. So what is variation? Excuse me. Variation is well known, obviously. I repeat once again. So what is variation? In almost all branches of our studies, physics, chemistry, biology, economics, etc., we are often concerned with the investigation of the relation between two or more variable quantities. By a variable quantity, or simply it is variable, say x and y are two variable, it is known to all of us, we mean a quantity which is capable of taking different values under the different situation. So, two variables, suppose two or more variables which are x and y. In this chapter, we shall study three types of changes. Three types of changes. That means three types of variation are here. It is written in the board, variation. There are three types. First one is direct variation. Second one is inverse variation. And third one is joint variation. First one, direct variation. Second, inverse variation. And third, joint variation. So first we study about direct variation. What is direct variation? Simply two variable, one is x and other is y. Direct variation means if x is increases, then y is also increases, or if x is decreases, then y is also decreases. Two variable, one is x and other is y, are said to be direct variation in such a way that x varies as y. This is the notation of variation. So sorry, it is infinity. This is variation. X varies as y. That means nothing but if x increases, then y is also increases, or x is decreases, then y is also decreases. So this is the right. Here we write the definition. Direct variation. What is direct variation? If two variable quantities, in this case we take not xy, we take AB. A and B are so related that when A increases or decreases in a certain ratio, then B is also increases. If A increases, B increases. If A is decreases, B is also decreases. In the same ratio, then we say that A varies as B, or we may say that A is proportional to B. A is proportional to B. The same things. Then we write A varies as B. Then we write A varies as B. For example, this is not example. Suppose A1, A2, A3, AN. A1, A2, A3, AN are, sorry, okay, now let A1, A2, A3, AN be the values of A, and suppose that B1, B2, B3 are the corresponding values of B. Then A varies as B means A1 by B1 is equal to A2 by B2 is equal to A3 by B3 in this way. Suppose this is K, that means value of A and value of B is equal to K, that means A by BK. A is equal to BK, where K is a non-zero constant. This K is called the constant of variation. K is called the constant of variation. Okay. So x and y are two variable, direct variation. That means x varies as y. That is, x increases, then y is also increases, or when x decreases, y is also decreases. Next, we study about inverse variation. Next, inverse variation. If two variables x and y are so related that when x is increases, then y is decreases, or in reverse, or in vice versa, x is decreases, then y is increases. Two variables x and y are so related that x increases, then y is decreases, and or x decreases, y is increases of the same amount. This is the definition of inverse variation. If two variables quantities a and b are so related that when a is increases in a certain ratio, b is also decreases in the same ratio. Or in other way, if two variables quantities a and b are so related that when a is decreases, then in certain ratio b is also increases in the same ratio, then we say that a varies inversely as b and denoted by a varies as 1 by b. So like previous one, a is equal to k times into 1 by b, that is a b is equal to constant, where k is non-zero constant obviously, and not only that, k is called constant of variation in this case also. Obviously k is non-zero, ab is equal to constant. For two variable x and y, or ab inversely variable, then a into b must be constant. A into b product of the variable must be constant. Then we conclude these two variables are in inverse proportion or inverse variation. Clear? So we go to the next. First we take an example of direct variation. Question from your book, question number 4.1. Y varies directly with square root of x and y is equal to 9 when x is equal to 9. Find the value of x when y is equal to 6. It is given that y varies directly with square root of x. So y varies as root x. Here we take positive square root. No problem at all if we take negative. So y is equal to some constant into root x, k not equal to 0 obviously, and k known as constant of variation. Y is equal to k root x. Now it is given y is equal to 9 when x is equal to 9. Just put the value y is equal to 9 when x is equal to 9 in this equation. So y is equal to 9, k into root 9. So k is equal to 9 by root 9. Root 9 that means 3. So k is equal to 3. Now put the value of k in this equation, then we get y is equal to 3 into root x. Now we have to find out the value of x when y is given, that is y is 6. Put the value of y is equal to 6 in this equation, we get 6 is equal to 3 root x, that means root x is equal to 6 by 3, that is 2. So x is equal to squaring both sides, we get x is equal to 4. If we take negative sign plus minus, then we get the same answer, no problem at all. Okay, this is the example of joint variation. First we study about this very simple sum, then we go to the joint variation. After we take an example of inverse variation, then we study about joint variation. Okay. Next question related with inverse variation. The question is x varies inversely with y, given that x is equal to 15 when y is equal to 8. Then find the value of x when y is equal to 5. X varies inversely with y, given that x is equal to 15 when y is equal to 8. We have to find out the value of x when y is equal to 5. So x varies as inversely, x varies inversely with y, that means x varies as 1 by y from the definition of inverse variation. So we can write x is equal to k into y, k not equal to 0, constant of variation like previous one. Write down, given x is equal to 15 when y is equal to 8. Put the value of x is equal to 15 and y is equal to 8, then we can write k is equal to 15 into 8, that is 120. So what is the relation? Just put the value of k in equation 1, we get the relation between x and y. X is equal to 120 by y. Now second part, value of y is given, value of y is 5, we have to find out the value of x. Just put the value of y is 5, that means x in this equation 120 by 5, then we get x is equal to 24. If y is equal to 5, then value of x is 24. Okay, very easy sum. This is the problem of inverse variation. Next, joint variation. First, we study what is joint variation. We learn about that. What is joint variation? Joint variation, if a variable is in direct variation, with the product of two or more variables, the first is said to be the joint variation with other variables. I repeat once again. If a variable is direct variation with the product of two or more variables, the first is said to be the joint variation of other two. Like that, if three variables we take for three variables, x is varies as y, z. If we take three variables, x is varies of y into z, product of two variables. So this is known as joint variation. Or in other way, we suppose we take x, y, z, p, q, r, s. If p varies as the product of other three, that means q, r, s, product of these three, then is said to be these are in joint variation. Joint variation, application of joint variation we have already known in physics, or it is in chemistry also. Combination of Boyle's law and Charles' law. PV is equal to prove. When we prove PV is equal to RT, most probably you are also known this. PV is equal to RT, well-known equation. The combination of Boyle's law and Charles' law. Boyle's law and Charles' law combination. PV is equal to RT. We have most probably you have already proved this. Okay, that is not in our study. Boyle's law, Charles' law in physics class or in chemistry class, physical science class. You are in class 10. So next we study about theorem of joint variation. This is very important. Theorem: if three variables x, y, z, be such that x varies as y when z is constant and x varies as z when y is constant, then x varies as yz when both y and z vary. I repeat, theorem of joint variation, very important, statement are very important. If three variables x, y and z be such that x varies as y when z is constant, x varies as z when y is constant, then x varies as y into z when y, z both vary. Proof is not in your syllabus most probably, but proof, here we give the proof of this also. Okay, first, x and y, x varies as y when z is constant. Is given x varies as y when z is constant. So we can write x is equal to k into y, where k is constant of variation. Very simple. X varies as y when z is constant, no matter z. So x varies as y means x is equal to ky, where k is constant of variation. K does not change with x and y. Okay, k is constant means k remains same. The change of x and y, with the change of x and y, x or y may be changed or not, k remain fixed. So next, another, it is given x varies as z. Next, k does not change with x and y. Next, x varies as z when y is constant. X varies as z when y is constant. That means instead of x we can write k into y. So write instead of x it is k into y, varies as z when y is constant. It is given y is constant. K into y. It is given y is constant, so write here y is constant. So k into y varies as z. So y constant. That means we can conclude k varies as z. Since y remain constant, we can conclude k varies as z. Now k varies as z means k into some k is equal to some constant into z. again constant of variation, that is L is the constant of variation, K is equal to L into Z, where L is the constant with regarded as K and Z. But K is constant with regarded to X and Y. K is constant with regarded to X and Y, it is given. K is constant with regarded to X and Y. And L is constant with regard to X, Y, Z. Therefore, we can conclude K is constant with regard to X and Y. Therefore, L is constant with regard to X, Y and Z. That means X is equal to K into Y. That means X is equal to K into Y. From this relation, we can write instead of K, replace K by L into Z. Instead of K, we write L into Z. Most of you did not see here. Wait. That means now instead of this K, in place of K, we can write L into Z. So X is equal to LZ into Y. That means since K is equal to LZ, L is constant with regard to XYZ. L is constant with regard to XYZ. Therefore, X varies as Y into Z. X varies as Y into Z when Y, Z both vary. This is the proof of the theorem of joint variation. X varies as Y into Z when Y and both vary. This is, I repeat once again, statement: if three variables X, Y, Z be such that X varies as Y when Z is constant, X varies as Z when Z is constant, then X varies as Y into Z when Y and Z vary. We prove this. It is not only for the three variable X, Y, Z, not only three, it more than three variable, then this theorem is also true. This theorem is also true for more than two variables, three variables also. Instead of X, Y, Z, P, Q, so say five variables, then it is also true. Okay. Next, question number 4.3 of your book. I read out the question first. X varies directly with Y and inversely with Z. When Y is equal to 5, Z is equal to 9, then X is equal to 1 by 6. Let us find the relation among three variables X, Y and Z. First question, we have to find out the relation between among X, Y and Z. And second part of the question, if the value of Y is 6 and Z is 1 by 5, then find the value of X. This question consists of two parts. First, we have to find out the relation between X, Y, relation among X, Y and Z. Okay. So, X varies as Y, it is given. X is varies directly with Y. So, X varies as Y and X is varies inversely with Z. So, X varies as 1 by Z. And just to learn about joint variation, if X varies as Y and X varies as 1 by Z, so one variable is Y, another variable in this case is 1 by Z. Obviously, Z is a variable. So product of Y and 1 by Z, that is nothing but Y by Z. So X varies as Y by Z by the theorem of joint variation. Here we write by joint variation. X varies as Y by Z. So K is constant of variation, non-zero constant. So X is equal to Ky by Z. We can write X is equal to Ky by Z. Now, given Y is equal to 5, Z is equal to 9 and then value of X is 1 by 6. If Y is equal to 5, Z is equal to 9, then the value of X is 1 by 6. So, put the value of X, this is the relation, X is equal to 1 by 6, K remains same, value of Y is 5, it is given, this is 5 and value of Z is 9. So, from this we can write K is equal to 9 by 6 multiplied by 5, this 5. So, 9 by 6 divided by 3, 6, 2 and this is 3. So, we get 3 and 5 into 2, that is 10. So, value of K is 3 by 10. Therefore, just put the value here, this is the relation, put the value of K here. the relation among x, y and z be x is equal to value of k is 3 by 10. So we put 3 by 10 y by z. So x is equal to 3y by 10z. X is equal to 3y by 10z. This is the relation among x, y and z. X is equal to 3y by 10z. This is the relation. Next part of the question, we have to find out the value of x, where y is equal to 6 and z is equal to 1 by 5. So if y is equal to 6 and z is equal to 1 by 5, then we have to find out the value of x. So using this relation, x is equal to 3, that is 3 by 10, and value of y is 6 and z is equal to 1 by 5, put here. Then we get 3 into 6, that is 18, and 10 by 5, that is 2. That means 18 by 2, nothing but 9. Therefore x is equal to 9. Therefore value of x is 9. So if x is equal to 6, z is equal to 1 by 5, then the value of x, by simplification we get the value of x, and that is nothing but 9. So very simple. Now second part is very simple. First, use the joint variation. X varies as y, x varies as 1 by z, so x varies as y by z. Then we can write x is equal to ky by z, where k is constant of variation. Then put the value of y, z and x, we get the value of k. Now put the value of k, we get the relation among x, y and z. X is equal to 3y by 10z. In the next part of the question, using this relation, put the value of y is 6 and z is equal to 1 by 5. We get the value of x is 9 after simplification. Okay, it's okay now. Next, 5.1. If x varies as y, then show that x plus y varies as x minus y. I repeat once again. If x varies as y, then show that x plus y varies as x minus y. First, the third question. Next, x varies as y. X varies as y given, then we can write x is equal to k into y, where k is the constant of variation. If x varies as y, then we can write x is equal to ky. Now take this quantity x plus y by x minus y. If we have to prove a varies as b, this is nothing but, if we prove a plus b is equal to constant, then proof are completed. If we prove a varies as b, now if we prove a by b is constant, then very easy. From this we can conclude a varies as b. So we have to prove a by b is constant, then the problem will be very easy. How? Follow me. We have to prove that x plus y varies as x minus y. Now if we prove x plus y by x minus y is constant, then it is very easy to prove. Now consider this, x plus y by x minus y. Now instead of x, in place of x we can write k into y. Just put x is equal to ky. Y remains same. In denominator also put x is equal to ky minus y. Since write down here x is equal to k into y. Now y is common. So if y is common, then it is k plus 1, y into k plus 1. Again y is common, then it is k minus 1. So y cancel out, y is obviously non-zero. So we get k plus 1 by k minus 1. That is equal to, if k is constant, k plus 1 is constant, k minus 1 is constant, division of two constant is also constant. So we can conclude k plus 1 by k minus 1 is another constant, say L it is. So x plus y by x minus y is equal to L. That means we can write x plus y is equal to L into x minus y. Since suppose this is L, so x plus y is equal to some constant into x minus y, that is nothing but x plus y varies as x minus y. This is nothing but x minus y varies as x minus y. Is it clear? Okay, then x plus y varies as x minus y. Next question, if question number 5.3, if A varies as B, B varies as 1 by C and C varies as D, write the relation of the variation among between A and D. A and D, what is the relation between A and D? It is direct relation or inverse relation. That means A and D are inverse proportion or direct proportion. So first we start from here. A varies as B. A varies as B means A is equal to K into B. A varies as B. This is A varies as B means A is equal to K times B, where K is the constant of variation. Second, it's given B is varies as 1 by C. So B varies as 1 by C implies that B varies as L by C, where L is the constant of variation. And C varies as D, that means C is equal to M into D, where K, L and M are constant of variation. Here we take three constant. One is K, other is L and other is M. So we can conclude K, L and M are constant of variation. Okay. Now again start from here. A is equal to K into B. Now replace B is equal to how much? L into L by C. Replace B is equal to L by C. So A is equal to, this is nothing but A is equal to KL by C. Again C is nothing but C is equal to M into D. Just replace C by M into D. Replace C. This is C is equal to M into D. So replace C by M into D. So we can write K is equal to KL by M into 1 by D. KL by M into 1 by D. Now K is constant, L is constant, M is constant. Product of two constant is constant. Division of two constant is constant again. So KL by M is constant. KL by M is constant. So we can conclude A varies as 1 by D. A varies as 1 by D. That means A and B are inverse variation. Therefore A and B are inverse variation, or A varies as 1 by D. It's okay now. A and B are inversely proportional. This also. If X varies as 1 by Y, then option which one is correct? X is equal to 1 by Y, Y is equal to 1 by X, XY is equal to 1, or D, option D, XY is equal to non-zero constant. Very easy. X varies as 1 by Y. That means we can write X is equal to some constant by Y. K is non-zero constant, that means constant of K is constant of variation. Therefore we can write XY is equal to K. That means which one is correct? Very simple. Which one is correct? K is constant of variation. Constant of variation. So obviously it is non-zero. So XY is equal to K. So correct answer will be D. Other than X is equal to 1 by Y, Y is equal to 1 by X, XY is equal to 1, all are false. This is partially correct obviously. XY is equal to 1, X is equal to non-zero constant, XY is equal to 1 is also partially correct, but it is not correct actually. It may be any constant, not only one. Okay.